Alright, for this last section, we're going to do the shorthand electron configuration. No need for the orbital diagrams, no need for the boxes or circles or lines. Here we're just going to base the first bits of the electron configuration for each of these elements based on the noble gas that's closest to, but not larger than, each of these. So here, first one is selenium. Selenium's got the atomic number of 34. It's in the P block, 4 rows down, 4 rows in. So the noble gas we're going to base ours off of is argon. Oops. So we've got argon. And argon has 18 electrons, selenium has 34. Argon is 3 rows down, so argon is going to pick up here, is going to leave off at 3p6. So where do we go from 3p? Well, 4s. And we can fit 2 electrons in there. And then from 4s we go to 3d and we can fit 10 electrons in there. And then 4p we need to get a total of like 16 more electrons. Let's see, 18 and 16 is going to give us 34. So we need we just need that as a 4. So 2 plus 10 plus 4 will give us enough electrons to make argon. Nitrogen, next electron, the next noble gas that's smaller than nitrogen is helium, and helium has 5 less electrons than nitrogen. So helium, it's one of the exceptions. It is in the P block, but kind of merely only honorarily. So neon's electron configuration is just 1s2. So instead of writing 1s2, we're going to save lots of time by just writing helium in brackets and picking up where 1s2 is leaving off. So after 1s gets filled, we go to 2s. We're going to put 2 electrons in there, and then 2p with just 3 electrons. So the 2 from helium plus these 2 plus these 3 will give us the 7 electrons that nitrogen has. Going to take a look at chlorine. Chlorine is also in the P block. To find the noble gas we're going to base our electron configuration off of is we go up 1 and over all the way to the right hand side of the periodic table until we hit the noble gases, and we find that the noble gas that's closest to without being larger than chlorine is neon. Neon's 2 rows down in the P block, so neon's electron configuration will end with 2p6, and we're going to pick up where that leaves off. So this gives us 3s2. After 3s2 gets filled, we go to 3p, and we only need 5 electrons because chlorine has 17 electrons, neon has 10. That means chlorine is neon with 10 more electrons. I'm sorry, with 7 more electrons. That's where the 2 and the 5 comes from. So iron, down there in our transition metals, atomic number 26. If we go up 1 row all the way to the right, we find that the noble gas that we're going to base our electron configuration off of is argon. Argon is 3 rows down back here, and argon has 18 electrons. Iron has 26, so we're going to add electrons until we get to 26 from 18. So we go from 3p6, which argon finishes up with, to 4s2, and then 3d 6, I believe. 1, 2, 3, 4, 5, 6. Yes. So 18 plus 8 will give us the 26 electrons that iron has. Alright, let's take a look at zinc. It takes a little bit down the road from iron. Same row, so we're going to use the same noble gas. 4s2, 3d10. It's the last one in the D block in the 3rd row for zinc, or for zinc. Francium down there in the lower left-hand corner of the periodic table. We go up 1 row all the way to the right, and we find that radon is the noble gas we're going to base this on. Radon has 86 electrons, francium has 87. Radon is 6 rows down. So we're going to pick up where radon leaves off, and that's going to get us to 7s. And it's just 1 more electron in there. And then lastly, polonium, down there next to bismuth. It has 84 electrons. We're going to go to xenon. And let's see, so xenon has 54. To go to 54 to 84, we're going to have to gain 30 electrons. So xenon is 5 rows down in the P sublevel. And we're going to go to 6s, 2, and then 4f14, 5d10, 6p4. That'll get us there.